So if you've ever heard somebody say that we are made of star stuff, like Carl Sagan or Neil deGrasse Tyson, shout out, we are made of star stuff. And that actually is, and we'll be talking more about this, but I want to introduce you to this idea. That is part of an ongoing process called galactic recycling. This galactic recycling has been going on ever since our universe, the space and time and matter associated with our universe, unfolded as part of what we collectively call the Big Bang. So back at the time of the Big Bang, okay, when our universe was just being born, actually, if you look at all the atoms, almost all of the atoms at that time were hydrogen, a little bit of helium, which is a smidgen of beryllium and lithium. So we'll talk more about this too. We'll talk a lot more about a little bit of everything, right? As I've listed these, hydrogen has 1 proton, helium has 2 protons, lithium 3, beryllium 4. They just are getting a little bit more complicated, a little bit heavier atoms. But if you look around the room or wherever you are and think about what are the atoms that are making up the matter that you're most interested in today, you're probably going to find matter that's got carbon, magnesium, iron, nickel, aluminum. Okay, all of these different elements, they were not around at the time of the Big Bang. The way we got these elements actually was by stars. Stars actually, we'll talk about how stars live their lives, and as they live their lives, basically they are making heavier and heavier things, elements, atoms of heavier elements in their cores, and also they're actually at their explosive end, they can do some other cool nucleosynthesis, some other cool making of heavier elements, even more heavier elements as well. But basically, everything that we have beyond these, hydrogen, helium, lithium, and beryllium, has been made by stars. It wasn't part of the original endowment as our universe began some 13.6, 14 billion years ago. So this idea of stars living their lives, they give their stuff up for new stars to live their lives, okay? And that is generally called a type of recycling called galactic recycling. So actually I have a little picture here to kind of show you galactic recycling. So this is like within the galaxy, okay? Within this galaxy we have stars doing this, okay? This is showing you a baby star. Okay, actually it is, you can kind of see these, how do I say this? It's a baby star. Let me go do this. Okay, can you see this kind of a frisbee, sort of a disc material? Okay, actually that is the stuff that is going to form the star. This is a protostar. It's not quite a star yet. You can kind of see this jets of energy. Okay, as a star is being born, sometimes those can get quite energetic, and yeah. So now this over here is a star is living its life and glowing and doing its thing, and we'll talk about how stars, depending upon how big they are, okay, they will live their lives at different rates and have different outcomes. So this right here is showing you actually the star that is kind of, can you kind of see this material sort of kind of ejecting off of that? That is, remember I said nebula? You know, I said that some of the Messier objects that he found were these clouds of gas and dust. Okay, nebula. This is a nebula that can be used for, guess what? More stars to be born. Okay, so that's kind of how that whole thing works. Yep, galactic recycling. So another thing about kind of scale of time, okay, galactic recycling, is this. I really think this is neat. Maybe you've seen this before, but what your author has done is basically take, this is the BB, stands for Big Bang, okay, right at New Year's, like New Year's Eve, yeah, midnight at New Year's Eve, okay, January 1st. I guess I should say midnight New Year's Day. Okay. Big Bang up here. And then here we are down here. Okay, so from the Big Bang to all within a year, how would you how would time major events fall? So, for instance, the Milky Way, our galaxy, would form in February. Okay, not till the month of September. Do you believe that? Not till clear the month of September. Here, September 3rd. Okay, would the Earth form around the sun. Is that not amazing or what? Okay, so from September 3rd to September 3rd to September 22nd, with the Earth formed September 22nd, we get early life on Earth. Okay. Now we kind of skip a few months. Okay, so early life takes a while to simmer. We have October, November, and now clear up to December. We kind of have to hone in on December. Okay, again, the Big Bang was January 1st, clear in December 17th. Okay, December 17th, we have the Cambrian explosion of life. December 26th, that would be what, 9 days later, we have the rise of the dinosaurs. Okay, 4 days later, we have the extinction of the dinosaurs. But check this out. That is December 30th, people. Oh my gosh. Okay. So, see, New Year's Eve is December 31st, right? So, December 31st, New Year's Eve, at 9 p.m., is that not crazy or what? At 9 p.m., early hominids evolve. Okay? At 2 minutes until midnight, modern humans evolve. Okay. So only 25 seconds ago, agriculture rises. 11 seconds ago, pyramids are built. What else do we have? Okay. You kind of get the idea. Is that not amazing or what, to kind of put things in perspective? The history of the universe in 1 year.